evaluate the definite integral using the substitution. So we have I is equal to square root of sine phi into cos phi to the power of phi d phi. So it's a clear indication to substitute t as sine phi. But this particular expression, well, if I do substitute that, what will happen to this? Yes, we have to make use of, your clue is this. Correct, trigonometric identity. But how? Along with our exponents. So let me do this for you guys. I'm going to consider cos phi to the power of phi. This is cos square, the whole square into cos of phi. So the square is 4. 4 plus 1 is 5, right? So I made use of the formula a to the power of n into a to the power of m, which is a to the power of n plus m. Agree? So now what do we have? We have, oh yeah, and after this also I need to do this. So cos square phi is nothing but 1 minus sine square phi whole square into cos phi. And so your integration will start looking like 0 to pi by 2 square root of sine phi into 1 minus sine square phi the whole square cos phi d phi. Agree? And now what do you substitute? Let t be equal to sine phi and dt is equal to cos phi d phi. So everything is set. Along with limits, we would like to change, right? That is better. Going back and forth does not make sense for this because it's a straightforward thing. So why not? So when x is equal to pi by 2, when I tell straightforward, I mean this. T is equal to 1. For x is equal to, let me change the language. For x is equal to 0, then t is equal to 0. Got it? So I is equal to 0 to 1 square root of t 1 minus t square the whole square dt. Agree? And after this you guys know what to do. So expanding this and then multiplying with root of phi. So my advice is try to do in your head and try to do it directly. What I mean is this. So a square minus b square is the a minus b the whole square is what we have to use over here. Along with that, root of t has to be multiplied. So we have a square into root of t. So basically root of t, because a square is 1 over here, plus b square is 3 to the power of 4 plus half is 3 to the power of 4.5. Okay. Minus 2 into a is 1 into b is t square. Along with that, this has to be multiplied. We can directly write it since we are writing everything. So 3 to the power of, this would be 2.5 into dt. Again, my advice is try to do this. If not, do systematically, you'll get the same thing. And integration of this, we're going to integrate a to the power of n, sorry, x to the power of n dx. Using this formula, we have the following result. So here it would be, okay, so this would be, we have, this is 0.5, right, t to the power of 0.5 plus 1 by this expression. So that will be 1.5, that is 2 by 3 into t to the power of 1.5. 1.5 is 3 by 2, right? That I have to invert over here, is it not? Because it has to come in the denominator. Again, try to understand and try to do it in your head. That's going to help. So this is 12 by 11 t to the power of 5.5 minus 2 into t to the power of, so this would be, how much is that? 3.5, that is 7 by 2, it is 2 by 7 over here, into t to the power of 3.5, and all in all we need to substitute 0 to 1. So this would be 2 by 3 plus 2 by 11 minus 4 by 7. Okay, so this is 21, 21, 3, 2, 1 in the denominator. And in the numerator, so this is 3366 plus 21, 42 minus again 33 into 4, that is 132. Hopefully I'm right with this. Okay, then a matter of subtracting, which 44 plus 66 plus 42 minus 132. Hopefully I didn't make any mistake. I have though. 3, 33, 66, 21, 21, 42, that's correct. This is, looks to be correct. Let me just take a pause. Okay, I found my mistake. It's 11 into 7 into 2. So 77 and 144. So 77 and 154. Okay. 54 plus 42 minus 132. Okay, we got it. So this is nothing but 64 by 231. Okay guys, a very stupid mistake, but anyways, it's a mistake. It happens. And this is your answer, right? The only difference over here is, here this 2 is getting changed, right? What I mean is the limit value is also getting changed. If not, it's the same procedure, same number of steps and all that I would generally advise, and same kind of writing, and everything is the same. Okay, you can pause and have a look.